Hello, everyone, and welcome to today's AWS reInvent session, Proven Security Best Practices for Defending Cloud Applications. My name is Mike Plant, and I'm the Vice President of Product Marketing in the Shape product group here at F5. We're really excited to visit with you today. As you probably are all aware, today applications have become the veritable fabric of our economies, our governments, and our lives. And it's largely how value is being exchanged between businesses and customers, between governments and citizens. This trend has been accelerated in 2020, especially as a result of the ongoing global health concerns. More and more businesses, more and more value is being stored and exchanged in our online and mobile applications. This important trend is not lost on fraudsters. That's why our applications have become a focal point for these fraudsters who are stealing more than $40 billion a year of value from our online applications. The total cost of this problem amounts to approximately $105 billion a year. That's made up of not only the dollar losses, but the actual money that's spent to make consumers whole from these types of incidents, as well as investments to investigate and remediate and prevent these types of unauthorized access to our applications. What we wanted to start out today with is a simple set of best practices that F5 has learned as we've helped application owners around the world in protecting their applications from unauthorized access and the resulting fraud and abuse. We really would like to help everybody engage on 3 simple layers to a defense in depth strategy for online applications. In order to keep your application online, you need to think about volumetric unauthorized access. And for this, you would normally look for a solution that provides distributed denial of service or DDoS protection. Then you need to focus on keeping your application from being accessed by unauthorized individuals who might be trying to take advantage of software vulnerabilities or exploit other problems in your application. And for this, you would typically look for a web application firewall. And then finally, you need to protect your applications from the types of unauthorized access that result in application fraud and abuse. Solutions such as an anti-bot solution or anti-automation solution, or even a full-fledged anti-fraud solution, depending on what vertical you're in. Now, this is a very simple framework, 3 layers of defense that help prevent applications from the consequences of unauthorized access and use. Now, it's a bit of a cat and mouse game. Unauthorized users and fraudsters actually try to get past whatever we do to defend our applications by basically telling 3 lies. Now, this framework sounds very simple, but in effect, it's very difficult to actually accurately determine if a user is an unauthorized user who is trying to present one of these 3 lies. The first lie is, are you human? Or perhaps are you in fact an unauthorized user that's in the form of a bot or some other form of automation that is trying to get into my application? The second question, the second lie, if you will, that unauthorized users and fraudsters propagate is, are you good or bad? What is your intent? Do you actually have legitimate intent as you try to access my application? And the third lie, the third thing that they tell lies about are you who you say you are? If you're presenting yourself as me, Mike Plant, to one of your applications, is it really Mike, or is it someone that's pretending to be Mike? Now, actually accurately determining if a user is an unauthorized user, a bot, or a fraudster, and they're actually telling one or more of these lies, is at the heart of how we can defend our applications from unauthorized access. CSO, one of the leading security media outlets, published their top security issues and concerns for fiscal year 20 recently. And they identified the number one cybersecurity issue in the world to be credential stuffing. Every time that you read about a data breach anywhere in the world from any application in the world, I'd like you to think about the word credential stuffing. Now, let me explain to you what credential stuffing is. Credential stuffing is where fraudsters acquire usernames and passwords or other forms of personally identifiable information from some other application or website, and then use that information in an unauthorized fashion to attempt to log into or otherwise access other people's applications. So imagine if I ran a travel and hospitality website and I had a data breach. The fraudsters might use that data to then go log into a number of other or attempt to log into a number of other travel and hospitality websites or financial services websites or e-commerce websites. They're banking on the fact that many consumers reuse the same usernames and passwords. Some of these data breaches also include enough personally identifiable information where sometimes the unauthorized access can take the form of trying to fill out a new application for a new account on your application, on your website or on your mobile app, because they have enough PII to accurately pretend to be somebody they're not. Now, this is not just an issue that CSO identified. There have been recent alerts from regulatory and federal agencies around the world, including the FBI and the Security and Exchange Commission here in the US, regulatory authorities in Australia, in the UK, across Europe. This is a major, in fact, the number one cybersecurity issue in the world, and it happens to be an application security issue. That's why we thought it was particularly relevant to discuss it at AWS reInvent. Now, this automated traffic, these unauthorized users and fraudsters that are using misappropriated data from these data breaches to, without authorization, access applications they shouldn't be getting into, it can have a broad array of both user and business impact. The nature of what the fraudsters and unauthorized users will do with that information can range from attempting to take over somebody's account. In the scenario I mentioned a minute ago, maybe an unauthorized user is pretending to be me to specifically take over my account. Maybe they're doing false new account creation. Maybe they're just using a whole bunch of data breach data to launch an application layer denial of service attack where they attempt to log into your application 100,000 times an hour or 200,000 times an hour just to overwhelm your application resources. These types of automated traffic can have significant impact on your customers, the people who use your web and mobile applications. It can create site disruption, site performance issues, of course. But when you have a situation where there's actually been successful account takeover, oftentimes we'll have backup security protocols in our applications that will shut down access to the account until we can get the situation resolved. That's a great thing. But if in the meantime I try to access my account that was subject to an attempted account takeover by a fraudster or by unauthorized traffic of some sort, I experience frustration. I may experience, monetary losses, even if it's temporary. If somebody has, without authorization, moved money out of one of my accounts or moved loyalty points out of one of my accounts. There's obviously a burden on your internal teams to both investigate and make whole consumers after these types of incidents. Oftentimes, these types of incidents results in heavy phone calls to your customer service desks. It has a lot of department level impacts across your company. And then finally, there's some pretty material business impacts. The fraudsters, the people that are doing this unauthorized access, are often, in there to try to get monetary gain. And so businesses that are subject to these types of automated traffic can experience even direct revenue lost, brand reputation and damage. It can be pretty significant. And so that's why we think, going back to that 3-layer framework of application owners should think about, for my website, for my mobile application, how do I think about protecting against distributed denial of service attacks? How do I think about defending against application vulnerability exploitation? And how do we defend against these automated attacks? The other thing that's important to think about is that once the unauthorized users start focusing on your specific brand, your specific company, they're going to follow this chain that we call the path of least resistance. If you set these defenses up for your web application and you happen to have a mobile app, but the mobile application doesn't have similar defenses, then this unauthorized traffic will typically shift quickly over to your mobile application. We've seen situations where that shift, where the unauthorized traffic will move from your web application to your mobile application, happen in as little as 7 to 14 days. Because they're still continuing to try to get value out of this unauthorized access. If your web application and any mobile application you may have are defended, but you have APIs that are open, public machine-to-machine APIs, they will attempt to exploit those APIs. And so our recommendation and the best practice that we've developed as we've advised businesses and brands around the world on these types of situations is to think about all the places where your business has an online presence that the market can see and can get access, and ask yourselves, what would unauthorized users and unauthorized access to this interface look like, and what should I do to defend it? One of the other ahas or learnings that we thought would be important for this audience to understand is that a lot of this unauthorized access, some of these fraudsters, this is a cybercriminal enterprise, and they're actually using themselves artificial intelligence to try to get past the defenses and the security controls that we put up around their applications. Many websites use a defense technology called CAPTCHA. If you're not familiar with it by that name, but if you ever remember solving those little square 3x3 puzzles that says click on the stoplights or click on the buses or click on the taxis, that's what CAPTCHA is. And there's many flavors of CAPTCHA, but one of the things that our security research team has identified as they've researched what cybercriminals and fraudsters are up to on the dark web is this the emergence of, think of it as cybercrime as a service, where these organizations that are trying to perpetrate this unauthorized access to your application, they can actually subscribe to AI-powered CAPTCHA solution services. Imagine for $1.39 US, you can get 1,000 successful CAPTCHA solves. Our friends over at Google did a study about how effective this machine learning or AI-powered CAPTCHA solution service is versus humans. And their research indicated that the human solve rate for CAPTCHA puzzles, right, real humans trying to figure out that little 3x3 grid, is 33%. By the way, I think the people that were in the Google study are better at CAPTCHA than I am, because I genuinely don't have a 33% success rate, I don't think. But the machine learning, the AI-powered OCR solve rates were in the 99.8% range. So this is basically saying it's a little bit of you have to keep an eye on your defenses and keep an eye on what unauthorized access looks like to your application. I'd like to give you one very quick tip, one thing you could do tomorrow to go and look at what unauthorized access to your application might look like. And I'm going to share with you an anonymized but real-world case study from a top U.S. telecommunications company. This particular telecommunications company For purposes of this example, we'll call them Example Wireless Company, was experiencing a surge to their login page. And this is what that traffic looked like from their perspective. They were seeing, and by the way, the vertical axis in this chart is logarithmic. In other words, it's much taller than it appears on the slide, but we portrayed it logarithmically so you could see the green traffic. Basically what this is each vertical line is an hour of time on this particular telco's website. And in that 1 hour of time, the green little bumps you see at the bottom was how many people successfully logged in. The yellow was how many people tried to log in but were unsuccessful, failed logins. That was very suspicious to this particular company. They weren't sure what was going on, and they asked F5 and specifically the Shape product group within F5 to help take a look at what was going on within their traffic. Something was fishy. When we took a look and analyzed their traffic, here's what we saw. Everything that you see in red was unauthorized traffic trying to log in to this telco's website. The stuff in yellow was authorized partner traffic, and the stuff in green was actual good human traffic. In this specific instance, remember the vertical axis is much larger than it appears, just so you can even see the green diurnal curve of the human traffic. The actual reality in this specific instance was 94% of the traffic to the login page for this specific web application, this website, was 94% from people trying to log in without access, without authorization. So the best practice, the thing I would recommend to everybody on this call that you do today, if you're not already doing it, and I know many of you are, is go sit down with your web team and figure out what does traffic to any front door page of our website or mobile application look like. How many, specifically for login, look at the login failure rate. In our experience, if you see a login failure rate greater than 20%, odds are that you probably have some degree of unauthorized access being attempted and potentially being attempted at scale. The other best practice that we wanted to suggest that you guys think about is that you have to continuously monitor and evaluate the front doors of all of your applications, web and mobile and API, because the folks that are perpetrating this unauthorized access traffic oftentimes will step back and try again. I've now shifted to a real-world use case from a major retail customer. And in this specific instance, again, the green diurnal curve you see faintly at the bottom, that's the actual legitimate human traffic to this particular website. The stuff that you see in orange is unauthorized access attempts. With this specific customer, when they first said, hey, can you help us? They specifically said, just give us the answer. What are we seeing? And we'll confirm your assessment. So we came back to them and said, everything that we've tagged in yellow appears to be an unauthorized access attempt. Again, in this specific example, it was 92% of the traffic to their login page was detected as unauthorized traffic. They said, can you please help us stop that? And we actually went into blocking mode and started automatically blocking the unauthorized traffic to this specific login page. Now, what ends up happening is in this specific instance, the fraudsters were trying to steal money from this retailer. And once their unauthorized access to this application was stopped, they basically gave up and went away. They weren't making money. This type of unauthorized access, this sustained unauthorized access, cost them money. So they just stopped, which again is the goal that we have. But if you look at the red blip that you see on day 14 and the red blip you see a little bit later on day, I guess it's about day 18, that's where they changed something in how they were attempting to access this application in an unauthorized fashion. Maybe they changed the freshness of the stolen credentials they were using. Maybe they changed how authentically they tried to simulate real human traffic. But nevertheless, it was detected as unauthorized access. It was immediately stopped. And after a couple of retooling attempts in this specific instance, they gave up and they moved on to another web property. They just gave, and that's at the end of the day our goal as a partnership. But it's important to understand that they're going to continuously try to retool. They won't permanently give up. Many of our applications are just too lucrative for them. Now, lest you think that we selected a couple of use cases from brands that had a particularly bad problem, F5 has observed this level of unauthorized traffic to most of the applications that we've evaluated in a variety of industries, from financial services to travel and hospitality, North America, Europe, Asia Pacific. So, one of the key insights that I would share with this audience is there's a decent chance that your application may be experiencing this type of unauthorized traffic. And again, the very first simple thing you can do to get a handle on understanding if that might be the case for your application is to just go do a simple assessment of login failure rates against your applications today. And that's something that, in partnership with your web team, if you're not already looking at it, you can actually get the data pretty easily from your web team. We believe that we should partner together towards a shared accountability model. When we talk to application teams, businesses that have web and mobile applications, the security teams within those businesses, we know that there's some real challenges when it comes to finding the right talented application security personnel and recruiting them, getting them on board, finding security personnel with application security experience who can help you with, do we have the right strategy for preventing unauthorized access through distributed denial of service attacks, preventing unauthorized access through trying to exploit vulnerabilities in our applications. Basically, what do I do in terms of a web application firewall? What should I do for anti-bot? So this shared accountability model, we believe that you can work with important, your existing, business partners, technology partners. You can work with our friends at AWS, and you certainly can work with F5 to, figure out what's the right approach together, both in terms of what is your application is experiencing in terms of unauthorized access today, and how we can together as a partnership put in place the right technology solution and the right answer from a staffing perspective to slash any losses that you may be experiencing from application fraud and abuse from this unauthorized access, how we can improve the uptime and performance of your applications by mitigating or scrubbing out all this unauthorized access. For those of you that may operate in regulated industries, how can we help you through this shared accountability model, improve compliance with any regulatory, whether it's PCI or other regulatory compliance? And candidly, how can we help you with a measurable degree of cost savings in your application delivery costs? If all of that, let's make up a number. Let's say that 50% of your traffic was unauthorized access. If we can help identify and correctly identify and accurately help you eliminate that unauthorized access traffic, it just makes your application performance better. It saves you money on delivering that application to your customers. It improves compliance. And frankly, in many, many instances, it actually helps slash fraud losses, because that's oftentimes what this unauthorized traffic is trying to achieve. The Silverline group here at F5 has a number of solutions available in the AWS marketplace that you can engage with immediately to both understand if you have any sort of unauthorized access challenge for your applications and actually begin stopping that problem. We have Silverline Shape Defense, which is specifically a solution designed to detect and stop unauthorized access via bots and other forms of automation that are typically trying to conduct credential stuffing. Silverline Web Application Firewall, again, stops those attacks, that unauthorized access where the people that are committing the unauthorized access are trying to exploit any vulnerabilities in your software application or infrastructure. And Silverline DDoS protection detects and stops those volumetric levels of unauthorized access, where maybe they're just trying to disrupt the performance of your website by submitting 100,000, 200,000, 300,000, web page requests an hour, or whatever that number is that would be more than your current application delivery threshold. And so these are all offered as fully managed services. They're offered with a single management console. You can have whatever degree of oversight and control on these set of security offerings that make sense for your business, your security team, and your application. But they are available as fully managed services. So there's a Silverline Security Operations Center that monitors unauthorized traffic to your website 24 hours a day, 7 days a week, and continues to tune and monitor and tune these three tools to help make sure that your application stays healthy, that your application stays operational, that it's high performant, and that this unauthorized access is accurately detected and mitigated without impacting your real legitimate users, the people in that green traffic. So I hope today's session has been helpful for you. Again, if you really want to start getting your arms around this problem today, go visit with your web team and take a look at what kind of unauthorized access are you experiencing to any of the front doors of your application. Thank you for your time, and enjoy the rest of AWS reInvent.